This is from day 12. True or false? Reasoning with standard deviation. So we've talked about MAD and IQR. Those are both measures of variability. Another measure of variability that we often use when we're dealing with statistics is called standard deviation. Standard deviation is a measure of variability. It's calculated using a method that's similar to the one that's used to calculate the MAD. But the math is a lot more complicated, and we don't really need to worry too much about how to calculate it because we also have technology tools that can do it for us. Deeper understanding of the importance of standard deviation will come with deeper study of statistics. For now, know that standard deviation is mathematically important and will be used as the appropriate measure of variability when mean is an appropriate measure of center. So that would be with your symmetric distributions. With a symmetric distribution, you're finding a mean, and you can use either MAD or standard deviation. The intuition you gained about MAD will also work with the standard deviation. So again, the higher the standard deviation number, the more variability there is. And we can use this number to compare data sets to each other. So the low temperature in degrees Celsius for some cities on the same days in March are recorded in the dot plots. We've got Christchurch, New Zealand, St. Louis, Missouri, Chicago, Illinois, and London. Remember, standard deviation and MAD are both a measure of variability. It has nothing to do with exactly what the smallest number or the biggest number is. It's saying something about the shape of the distribution. So if you have two different sets of numbers, even if the numbers are different, if you look at the shape of their distribution and they're the same, they should have the same MAD and they should have the same standard deviation. So standard deviation of Christchurch temperatures is 0 because the data is symmetric. Is that true? Standard deviation of St. Louis's temperatures is equal to the standard deviation of Chicago's temperatures. Is that true? Is the standard deviation of Chicago's temperatures less than the standard deviation of London's temperatures? Well, if the standard deviation of Chicago is going to be less than London, that means that the data set is going to be a tighter grouping, a smaller grouping. It's not as spread out as it is in London. Check the dot plots and tell me if it's true or false. If you're still not entirely sure about this variability thing and how that translates into the graphs and the standard deviation number, please let me know. I want to help.